Hi class. Now this is our ninth online lesson and our last in the series of dynamics. So with this slide, we'll finish chapter 4, 5 and 6 from your textbook. This last concept is law of conservation of momentum. So the total momentum when there is an impact between when two objects collide, the total momentum before impact is always conserved, as in the total momentum before impact will always be same as the total momentum after impact. You can read this. I'll just go through the main point. So momentum before impact, if I take u1 and u2 as the initial velocities of the two particles in impact, and v1 and v2 are the final velocities of the object in impact, mass into velocity, m1 and m2 are the mass of the two objects respectively. So momentum, mass into velocity equals to mass into final velocity, mass into final velocity. This is the formula for the law of for the conservation of momentum. Total momentum before collision same as total momentum after collision. Let us take an example. Okay, particle A and B have masses 0.5 kg, 0.2 kg respectively. They are moving with speed 5 and 2 respectively in the same direction along this. Okay, I'll draw a scenario here first. So this is what is happening before collision. So this is my way of doing it. I just draw a line and draw the situation before collision this side and after collision this side. So there are two objects A and B. Before collision they are moving with velocity 5 and 2 respectively in the same direction. So you can see the arrow in the same direction. The question says after collision A continues to move with the same direction. So after a collision A is in the same direction with a velocity of 4. So we know this is also 4. Find the speed of B after collision. So we have to find, see, obviously because both are moving in the same direction and after impact they're going in the same direction, B will obviously go to the rightward. Yani there's no logic that it will reverse. Even yani, let us say there's a question in exam where you don't know where it is moving. You can take any direction as positive, as I told you before also. It is a vector. So it doesn't matter if your assumption is correct, you will get a positive answer. If your assumption is wrong, you will get a negative answer, and hence you will know the direction is reverse. Now let us take the formula. So this is the formula for momentum, mass, velocity. So this is mass into velocity, initial mass, and again you have to be very careful that you mention this in exam. You're taking this as positive. So mass is 5, velocity, mass is 0.5, sorry, velocity is 5. So mass into velocity plus this. Now this mass into this velocity, this is where my pointer is. So this is the total momentum before impact going to the right side. Now this is the mass velocity of the first object, mass into velocity plus mass into velocity of the second object. So this together is the total momentum after impact. You just simplify this, simple mathematics. Velocity is 4 and you got to 4.5 meter per second. You got a positive answer, obviously, which means that this direction is correct. Let us take another example. I think this is a very easy topic. We understood with this example. Pause your video here, try to do it on your own, and then when you are ready you can start the video. Okay, I will draw this again. Let me draw this. The question says two particle A and B. Again, as I said, I'll draw like this before, draw a line, I draw after here. So they are the two particles of mass 2 kg, 5 kg. Okay, now they are moving towards each. This is very important, towards each other. So the arrows are towards each other, so they are going this opposite direction. Okay, now the question says the particle collide. Before collision the speeds were 6 and 4, which I wrote here, 6 and 4. After collision the direction of motion of A is reversed. So A which was going rightwards will now go leftwards. So we know the direction will be reversed with a speed of 1.5. So we know this is 1.5 also. The speed and direction of B. So we don't know the speed, we don't know the direction. Again, I'm just assuming that this will be positive. Okay, and if I get a positive answer, my assumption is right. If I get a negative answer, I will know that it will also go in the opposite direction. The same formula. So mass into velocity plus this mass into this velocity. Again, you have to mention this, that you are taking right as positive. So 6 will be positive, whereas 4 will be negative. Same, 1.5 will be negative because it is opposite to this. And because I took this arrow as positive, I am assuming it is moving this side, and which matches with this. So that's why it is positive. When you solve this mathematics, you get a -1. So that means my assumption was wrong. It is actually going in the opposite direction with 1 meter per second. So how you will answer? You can say the speed of B is 1 meter per second. Direction is not reversed. or unchanged? See, initially this is particle, correct? Initially it was moving left, and we know that afterwards also it is moving left, so we can say direction is not reversed or it is unchanged. Now let us come to the second part, the impulse. Again, the question says impulse given by A to B, from A to B. So A to B is this direction. So I am taking this direction of impulse as positive. Remember, impulse are taken from the same object. So final momentum of B minus initial momentum of B. Don't do the mistake of taking A and B. It has to be from the same object. So final momentum of B minus initial momentum of B. Now because I am taking this as positive, this is opposite, so it will be, we have to take -1. This is the minus from the formula, this formula here. And again, because this direction is positive, this 4 is opposite to that direction, 4 will also be negative. Solve the mathematics. Impulse is 15 Newton second. Let us move on. This is a question. Read the question carefully. This is question number 9 in your textbook. I have drawn this diagram for you. Try to do it on your own. Let's go to the next one. Okay, this also, read the question carefully. This is question number 11 in your textbook. Similar situation. Try to do it on your own. Okay, with this we actually finished. We done with dynamics. I'm just taking a question from chapter review. This is a higher order question, so I want you to be very careful. Pay attention now with this question. The question says a pile driver of mass 1000 kg drives a pile. There's something going in the ground, that is called a pile, and pile driver is the one with which you hit, or basically it is dropped from a height to hit that object. So pile is what is going under the ground. We want to put underground, put inside the ground, you can say, and this is the object that you drop from a height. Pile driver of mass 200 kg vertically into the ground. The driver falls freely. So initial velocity is 0, gravity is 9.8, s is given before hitting the pile. Okay, what I'll do is I'll draw this. So this is what is happening. So this mass 1000 kg is dropped. So initial velocity is 0. It is traveling a distance of 10 meters under the acceleration of 9.8. We have to find the velocity with which, find the speed of the driver immediately before it hits the pile. So what is the speed with which it hits here? Simple, you know 3 information. You can find the fourth by using kinematics. So you know u, you know s, you know a. V square is u square plus 2as, and we got velocity s 14 meter per second. Now find the common speed of the pile and pile driver immediately after impact. See, now the question goes in before impact and after impact. So this is the question of momentum and impulse, what we did earlier just now. Let's go to the next slide. So they want us to find the common speed. Okay, so see, actually this situation is vertically. This is happening vertically. This is up, this is down, but just to make it for simplicity, we make the setup horizontal. So this is falling, okay, after, when the impact happens, just when the impact happened, the velocity of this pile driver was 14 meter per second. This is what we just found, and because this was at rest, it was kept on the ground, so velocity is 0. This is before impact. What they are saying is after impact they are assumed to be moving together with a common speed. So they are joined together with the common speed. We use the same momentum formula. So 1000 into 14 plus 200 into 0, which is 0, is 1200 v, and that's it. We got the combined velocity as 35/3 meter per second. The last part of the question now says the ground provides a constant resistance to the motion of the pile driver of magnitude this. Now there is a resistance. So something is, now we are going, the object is in motion and there is a resistance. So we are going into dynamics now. So let us draw a situation of dynamics. So this is what is happening. They are going together of mass 1200 kg. So let us draw the dynamics, the forces which are acting. 1200 is the mass, so the weight will be 1200 into 9.8, 1200 g. There is a resistance, they said, of 120,000, and it is going down with the acceleration of a. The same thing, the resultant force F equals to ma. The resultant force, if I am taking downward as positive, this is negative, and mass into acceleration. We know mass a is what we have to find, so acceleration is minus 90.2 meter per second square. Okay, we got the acceleration with which they are moving. Now the question is, find the distance that the pile is driven into the ground before coming to rest. So we have to find the displacement basically. We know the acceleration, we know the initial velocity after impact was 35. So when the impact, after impact, the velocity became 35 by 3. It has to stop, come to rest, so v is 0. We know acceleration is minus 90. Simple kinematics formula. Use the formula you can of s, u, v and a. You will find 0.75 meter. This is the distance it will go inside the ground. That's it. Let's take the next slide. See, this is one of the question from past paper. I want you to go through this question, especially the one I have put this in box. Try to solve this question. Later on, I'll make a slide and send you as I'll make a worksheet on this. I'll solve and send you. Okay, so try to do it on your own. The next question also is same. This is again, this question is also from one of the past paper. I want you to solve this question, and as I said, I'll make a worksheet on this later on and send you. This is the same thing. They want you to find thrust. We studied this earlier. I'm just putting it down here so that it's a revision for you. Try to solve this. So this 3 questions, try to finish it, and we are done with this. Dynamics is over. Inshallah, I'll come with the remaining 2 chapters. All the best. Goodbye.